Dear students, today I am going to take up a simple problem related to the slider crank mechanism. In this slider crank mechanism, we are going to find the velocity analysis. We are going to do the velocity analysis by using graphical method. As you can see, the problem here it is here. In a slider crank mechanism, the crank OB is equal to 30 millimeters and the connecting rod PC is 120 millimeters. The crank rotates with a uniform speed of 300 rpm in the clockwise direction and makes an angle of 60 degrees. Right? Okay. Find the velocity of the piston, that is C, and the angular velocity of the connecting rod BC. This is the case of slider crank mechanism. You know that in a case of slider crank mechanism, we have the four links. One is frame, which is fixed. Second one is the crank. Third one is the connecting rod, and fourth one is the slider. So in this, the crank speed is given. It is 300 rpm. So we are supposed to find the two values, that is the angular velocity of the connecting rod, at the same time the velocity of the piston. Here we are not calling it as angular velocity of the piston because piston is moving in the linear fashion. So there won't be any angle to that piston. Since the piston is moving in a linear direction, therefore we are going to find the linear velocity only. So this is a given problem. So again, the first and foremost thing is that I think you might have understood the problem here. So we are going to find out the velocity analysis for the slider crank mechanism. Okay. So what I will do is, so after reading the problem, I will try to erase and I will try to solve the problem. Okay. So it is given data, you can see here. The crank is given as 30 millimeters. It is there. Connecting rod BC is 120 millimeters. N is equal to 300 rpm. Theta is equal to 60 degrees. Now, what we are going to find is, again as I told you, the VC, that is the velocity of the slider, and angular velocity of the connecting rod BC. Since the lengths are 30 millimeters and 120 millimeters, so first and foremost thing is that we are going to draw the displacement diagram. The first step is, that is step 1 is the displacement diagram, right? Displacement diagram. So when you want to draw the displacement diagram here, since the lengths are 30 millimeters and 120 millimeters, I think you can consider the scale as 1:2 only. There is nothing wrong. So because the lengths are very small, this 30 millimeters means it is 3 centimeters. It is 120 millimeters means it is 12 centimeters. First and foremost thing is that when you want to draw the displacement diagram, I will consider any point O here, right? So I will try to draw the crank 30 degrees. No, it is making an angle of 60 degrees. Length is 30 millimeters. So this is with this horizontal line. I will draw a line which makes an angle of 60 degrees, right? This is 60 degrees. And if you cut this, 3 centimeters or 3 millimeters. So here we are going to get the point as B. This represents the crank. This is rotating in the clockwise direction. It is given in the problem. It is rotating in the clockwise direction, right? And when you want to draw the connecting rod from B, the length is given as 120 millimeters from B, right? So what you can do is measure the length of that is 120 millimeters or 12 centimeter. So you just from B as center, just draw an arc here to cut this horizontal line and join this from B to this line. You join this point is our C, right? Here the point, the slider is the place. The slider will be moving here. This is the crank and BC is the connecting rod. Okay. So after drawing this displacement diagram, so I have considered the scale as I told you 1:1. So the speed of the crank is given as 300 rpm. N is given as 300 rpm. Therefore, we try to calculate the value of, that is omega B, because the angular velocity of the crank we try to find. So omega B is equal to, it is 2 pi n by 60. That is 2 into pi into n is given as 300 rpm divided by 60. If you just calculate, we are going to get the value of the angular velocity of the crank, that is equal to 31.416. This is equal to 31.416 radians per second. So we got already the angular velocity of the crank. The next thing is that to find the other velocities, what we do is I will try to draw the what is known as velocity polygon. So before we try to draw the velocity polygon, let us try to convert this into the linear velocity, right? Angular velocity is known. So if you want to find out the linear velocity, so we know that the value of the VB, that is linear velocity of the B, is equal to, so you know that V is equal to R omega. R is nothing but it is the length of the link OB into omega, that is omega B into OB, right? So omega B is 31.416 into, so the length OB is given as 30 millimeters. If you just convert into meters, it is 0.03 meters. This value, that is the linear velocity of the link B, that is VB, is equal to 0.9425, 0.9425, that is meters per second. So this value is known, 0.9425 meters per second. So after knowing this, the linear velocity of the link B, so what I am going to do is I will try to draw the velocity polygon. So I will consider the point O somewhere here, right? So this velocity, this angular velocity is, it acts in which direction? It acts in a direction perpendicular to the link OB, right? Since the OB link is here, so the velocity vector acts in a direction perpendicular to the link OB. Therefore, from O as center, I will draw a line, right, by perpendicular to the OB, which is equal to 0.9425. Here, to draw the velocity polygon, again I am going to consider as scale, which is equal to, so 1 centimeter is equal to 1 centimeter is equal to 0.9425. 1 centimeter is equal to 0.9425. Sorry, I will consider the scale as 1 centimeter is equal to 0.2. 1 centimeter is equal to 0.2 meters per second. I am going to consider. So with this scale, 1 centimeter is equal to 0.2 meters per second, and I am going to draw. So 0.9425 divided by 0.2. What are the value you are going to get? So that value. So you try to draw a line which is perpendicular to the link OB. This point is our O, right? This point is B. I am going to get, right? And second velocity is from B. So the velocity vector will be perpendicular to the link BC. The velocity vector will be perpendicular to the link BC. So from B, draw a line perpendicular to this line. Its magnitude is unknown, but direction is known. How the direction? Direction is perpendicular to the link BC. So from B, you draw a line which is perpendicular to the link BC. Its direction is known, but magnitude is unknown. Just leave it is. So the third one is, now we have to find out the point C. You know that the slider is moving in a linear direction. So naturally, its velocity is parallel to the, because linear velocity, its direction is always parallel to the direction of motion of the slider. Therefore, from V, you draw a line which is parallel to the link OC. So if you draw this parallel to this, so we are going to get the line length. Therefore, this is VB, right? This point is, the point of intersection of these two is, this is the point C, right? And so we know that this is that VC. Direction is it's going out, it is in the right side direction, because when the crank is rotating in the clockwise direction, so VC is also moves in the right side path. And this is, that is VBC. That is VBC. This is the velocity polygon we have completed. So how we have drawn the velocity polygon? By considering the scale, 1 centimeter is equal to 0.2 meters per second. So after knowing this, we are supposed to calculate the linear velocity of the link C and the angular velocity of the connecting rod. So to find the linear velocity of the link C, right, VC, that is, which is equal to, that is OC into scale. OC into scale. So from this, if you measure the value of OC, you are going to get as 4.6. Scale is 0.2. So which is equal to the velocity of the slider is 0.92 meters per second. This is 0.92 meters per second. It is the linear velocity. We did not convert into angular velocity because it is in linear motion. The second one is we try to find out the linear velocity of the connecting rod BC. That is VBC is equal to, we know the formula, what is that? BC into scale, right? BC into scale. This value of BC measure into scale. So if you measure this, we got this point as 2.4 into scale is 0.2. So the value is, we are going to get as 0.48 meters per second. That is the linear velocity. But since the connecting rod is oscillating, we are supposed to find the value of omega BC. So omega BC is equal to, so we know that VBC divided by BC, because we know that V is equal to R omega. R omega is equal to, that is V by R. P is, we already calculated, that is 0.48 meters per second divided by, it is BC length. If you measure the length BC, it is 0.12. BC means not length, not this length, the length of the link. The length of the link, it is 120 millimeters. So if you convert in meter, it is 0.12. We are going to get this value as 4 radians per second. So we found, what is that? We found the linear velocity of the, that is the slider as 0.92 meters per second. The linear velocity of the link BC or connecting rod is 4.48 meters per second, and the angular velocity of the link BC is 4 radians per second. So this is how the velocity analysis is done for the case of simple slider crank mechanism. So only thing is that, so here we have considered 1:1 scale here. When you are drawing this velocity polygon, I considered as 1 centimeter is equal to 0.2 meters per second. This is the method to find what that the linear velocity as well as angular velocity of the different links. Thank you.